a language which is, and the reason is that Ruby is very flexible. What does it mean by a dynamic or dynamically typed language? A language that doesn't have either a compiler or the compiler is way too lenient to enforce types at compile time or code writing time, and then it does certain things at runtime. A language is weakly typed if it doesn't enforce anything at the runtime, but Ruby does check for things at runtime, so it's usually a dynamically typed but strongly typed language as well. Ruby is highly expressive, and it has less clutter. You don't have to write any unnecessary code. For example, if you want to write a hello world in C#, you would first have to write a class, isn't it? And then you have to write a main method in it. In case of Ruby, you simply write the most minimal code you can get away with. So here is my hello world in Ruby without much effort at all. Just write whatever you want to write and run it, and becomes very lightweight. This, by the way, is what is referred to as low ceremony. Ceremony is when you are forced to do stuff that you don't have to do. And a lot of these lightweight languages have low ceremony and high expressiveness and conciseness baked in, so you can get to work really fast rather than doing things that force you to do stuff that doesn't matter. It is dynamically typed. What does that mean? I can define a variable, let's say variable v equals 1, and this value, of course, is 1 at this point. I can change it to something else if you like, and I can print that value also. And Ruby will just allow you to do it. And this is good and bad, right? It's bad because from the frame of mind that we have in static typing, this freaks us out. It's like, oh my God, you don't have control over what the type of this variable is. But you can leverage this also and say, it doesn't matter whatever the object is at runtime, that's what it is. So this leads to what is called the duck typing. The word duck typing comes from the little statement that it walks like a duck, quacks like a duck, it's got to be a duck, right? So that's what duck typing really is. Dynamic type languages are duck typed, so it's very flexible from that point of view. But of course, you got to be careful to know what type you're dealing with. But not more from the type point of view, but from the functionality point of view. It's fully object-oriented. What does that mean? So I could say -1.absolute to get the absolute value. So notice, there is no primitive types and built-in types and user-defined data types. There is just objects. Everything is an object, and you can just call methods on it, and it becomes easy to work with it. Similarly, I could say, take a hello, and I can call, for example, toUpper on it, and ask him to upcase it. So you can ask it to perform methods that can be applied on strings and so on. It becomes a lot easier to work with. There are certain conventions that Ruby expects you to follow. There is a good news about conventions and a bad news about conventions, right? The bad news about convention is, if you don't know what the convention is, you're totally lost. This is like being in a new city, and there are people walking on the wrong sides of the street, right? And you go crash on people for a few times, and then you figure out, maybe I should walk on the other side of the street. It's like that. So you got to kind of know what the conventions are. But once you know what the conventions are, life becomes very easy. You're not wasting your effort. In the case of C#, you define fields in classes, and then you define properties, and then you define functions. That's quite a bit of baggage that we have to carry. Let's take a look at how we would write a class in the case of Ruby with all these low ceremony in place. So I'm going to say class car. So we are writing a class. So notice, I'm going to create an instance of it. So we could say car.new, and I have created a car instance. Right there is my car instance. Now I want to drive this car, but I'm going to initialize. This is kind of like a constructor, and I say miles equals 0, because when you start a car, you want the car to have 0 miles. This also shows you a little bit of another detail as well. We'll come back to it. Now I want to drive this car. So what do? Drive is a function for what? Distance. And how much do I want to drive? Miles plus equals distance. So now you're driving the car, so we can say car dot drive 10 miles. And I can now say, what is the miles driven, right? I could ask the car for the miles driven. We'll come back to it. So the car was able to drive, it changed the miles, but how do I get the miles really? I can define an attribute reader for the miles itself and get the value. So now I can say car.miles to print the value of miles. Notice it tells me it's 10. I cannot modify the miles. Car.miles equals 0 again, right? I know what you're thinking. That's one way to keep the car new all the time. You go on long trips and reset the miles, right? No such business. It's read-only. How is it read-only? Because you told him so. Attribute reader, not attribute writer. So as a result, he makes those as read-only attributes because we told them so. But notice that you did not waste your time and effort defining a field. Hey, what is a field of a class then? Use an @ symbol in front of it, and that becomes a field automatically. It knows that it's a field. You didn't have to waste your time defining it explicitly. So it's a language that kind of intelligently figures the details out. It goes a little bit further with these things, by the way. Notice the subtle difference here. Puts car. Look at the error. The error message here tells me that car is uninitialized, but notice the wording. Uninitialized constant car. It thinks it's a constant for some reason. But if I change this C to a lowercase c, notice now what it tells me. It says uninitialized local variable or method. So in Ruby, the convention is use lower cases for methods and local variables, uppercase for constants, and class names are constants because they become pointers to the class object once you create it. So once again, the language kind of lives and breathes these conventions, and you have to know these conventions to be productive in the language. That's a bit of a downside. But for that small price you pay, it removes the effort overall. So you look at the difference, right? In a language where you don't have to know the convention, you get beaten every time you write the code because you got to write more code. Here you don't write that code, but you better know the convention, what to use. So a little bit of a learning curve, but it takes away so much burden from our shoulders as we go with it. So that is basically what you're seeing here in this, that it is able to figure out these conventions. I want to display an expression of values. This is kind of similar like C#, but not entirely. What do you do in C# when you want to create an expression, a string with values in it? You would say console.writeLine, isn't it? And then you would put some stuff, and you put a curly 0, curly 1, curly 2, and then you would say comma separated and put those values, right? Sure, that's fine, but can it be simpler than that? So how about name equals, Joe? So I have a name called Joe in this case, and I'm going to simply say put the name is name. So notice here that I put a pound symbol. And I said the name is a pound symbol, a curly bracket, name, and what happened? Not what you may want it to happen, right? It just printed that. And that is because, notice I used a single quote. A single quote is just a literal, that's all it is. But I'm going to now go back and redo this, but this time I say puts double quote, the name is pound name. What you see here is an expansion of the string. So you can embed variables in strings, and as long as it's double-quoted string, it expands and substitutes those. What's the benefit? Imagine you're creating a web application where you have a certain text you want to display, but part of it are expressions that need to be evaluated. You can simply put variable names, and when you render the page, it's going to replace all those variable names with the content you want to display. Efforts minimized, right? So that basically becomes a lot easier to work with, and you have these string expressions that you can have and you can use very nicely. So in terms of writing the class itself, you saw me show an example of writing a class, but when you write classes, you want instance variables. And how do you know it's an instance variable? With the at, right? Yes? Otherwise, I'll start over the talk one more time. At symbol? All right. And how do you write a function? You put a def and then what? Lowercase function name. Don't make it uppercase, right? That's needed. And class name itself starts with an uppercase. Some other conventions that Ruby uses, you use underscore to separate names, multi-named names, right? A bank account, bank underscore account. You use underscores to separate these things in the case of Ruby for readability. But you can also have static methods. Can somebody guess how you would know something is a static variable? How do you know it's an instance variable? At. So how do you know it's a static variable? Do at. Right? Sure, why not, right? It's at a meta level, isn't it? So one at is the instance, two at is, you think I'm making it up, don't you? No, I make jokes, but not on these things. So let's go ahead and try this out. So we have a class called car, and I want to say here, create a car, so initialize, and I'm going to initialize the car. So we could put information, a license or our ID equals, let's say 1. But all these cars are going to have the same ID. We can change that. We could say ID, and this becomes the ID. Isn't that beautiful? Did you just notice something that we did? Have you ever seen a C# code where somebody writes this dot variable equals this? I strangled them right away at work. Okay, not that brutal. But I really hate that. Why? Because this dot is a noise in the code. And then you end up shadowing variables. It becomes a pain, right? Notice how naturally this was fitting in. At ID equals ID, right, that you received, you set it up. Okay, nice. What do we do then? And I'm going to say, you can write functions. We can do that. So we can say car1 equals car.new 1 and car2 equals car.new 2. Did you notice something already as I was doing this? You didn't say new car. You said car.new. Notice the consistency. Car is just another object. It's just an object of class. And it's a factory. Call new on it, it produces a little object for you. So notice how nicely it fits in, right? You're not playing with two different things. Oh, new of class type, and then you have to call static method as class name dot something. Question? No? So it's very consistent in that regard. Just call new on it. You can also basically go back to this, and now you can say self dot, so define self dot some function, right? Whatever function you want to write, some function. I don't know what I would write on a car. I'm just throwing an example together. And now this foo belongs to the class, not to an instance. Maybe we could say, get count, count. So what is count going to return? It's going to return the count. Oh, that's another thing. You don't waste your time putting the returns. Returns are automatic. But there's yet another distinction in Ruby that makes a huge, gives a huge benefit in programming. Ruby has no statements. Does C# have statements? Yes, an if statement, right? Why are statements such a bad idea? Statements make it harder to write code. We don't realize it. Because a statement returns nothing. A statement is stubborn. It says, I will do some work, but I won't tell you anything about what I did. That's what a statement is, right? But on the other hand, an expression is so beautiful. It does its work and gives you back something, right? And it gives you a result. So it's easy to compose expressions, but it's very hard to compose statements. And in fact, if you only have statements, you have to have mutable variables in it. Whereas expressions are much more superior. And in Ruby, everything is an expression. And again, the last expression's value gets returned in this case automatically. So what am I going to do here? I could say, in this case, a count equal to 0, right? I'm initializing the count value. I want to know what the count is. So I can go up here and say put car dot count. I'm asking him to tell me what the count is. It is 0. I'm going to ask him one more time, hey, what is the count of the car? Please tell me. And it remains 0. It's kind of sad because we created 2 cars, didn't we? But I can go back here and say count plus plus. I can increase the value of count. Plus equals 1. Right? We can increase the value of count. And now each time I create an instance of a car, the count is going up, right? So you can see how static variables are also fairly easy to maintain, and we can use a double at to create them. What about collections of data? I want to use an array of objects to play with. So we could say numbers equals, and I can create an array of values, whatever those values are. It puts numbers. So this is going to be just the array of values. And once I get the array of values, numbers, what do I want to do with it? I can say, I want to loop through, well, what's the type of this? Numbers dot class, curious. It's an array type. But I want to loop through it. How do I loop through these collections? So I'm going to say for a number I in numbers. And I want to print the value of the number. That's like our, what is this equivalent in C#? For each, that's correct. Not the for, but the for each, right? That's equal to for each. So this is basically iterating through the collection and printing the data. But you don't have to do that. There is another way to do it, to use what are called internal iterators. You can say numbers dot each. And for a given element E, I want to print the element given to me. So that is an internal iterator that you can write on the collection. And that gives you an ability to loop through the values and print it. Makes life easier, isn't it? So that is another example how you could use the iterators. But this only begins, opens up the possibilities. I want to be able to get a certain element out of this. What do I want? I want the first even number from this collection, which is 2. But I don't know that, let's say. How do I get the first even number? So I can say put numbers dot find. What do I want to find? Given an element E, get the element which is even. So notice how you are applying a find operation, and that is able to find the first element. How does this work? It's functional style in nature. And by the way, what is the equivalent of this in C# today? 2 words. Starts with the L. Lambda expressions. Notice how close to this it is, right? Not too far from this, isn't it? You would put a curly parentheses, E arrow, and then you do equals greater than, and then you put the code in it, right? So C# has done a fairly good job in catching up to this and providing such a construct, isn't it? So that is an example of how you're able to find a value. You say, wait a second, but I want all the even numbers, not just the first even number. How do I get it? So what am I going to do? Very simple. Simply say, hey, excuse me, why don't you find all rather than just the first one? And you find all the values in the collection. So that was easy, wasn't it? You say, okay, that's fine, but I want to take each of these elements and I want to total these values together. How do I total these values together? So total equals 0, and I'm going to print the total when I'm done, right? That's 0, but I want to total these numbers, right? Numbers dot each. And I'm going to say, in here, given an element, total plus equals E, and I can do that. That's still functional and styled, right? But notice how we mutated this value over and over and over. You say, well, can you do this without mutating values? Can you just, kind of do this with complete immutability on hand? Absolutely, we can do that. And we can do that by using what is called an inject method. It's a little bit more complex than what we saw. But I'm going to print out numbers.inject. And what does inject do? Takes a parameter, and it takes a body of code, with two things, a carryover and a current element, and simply returns the current element over plus the carryover value, right? So that is basically what it's going to work with in this case. So what's he dealing with in this case? Reduce, I believe. I can't remember in this case, at this time what the call they are using in Ruby. I play with different languages, and right now I can't remember what it is. Actually, it says 0 is not a symbol. Not sure exactly why he is complaining about that. Or maybe it is because of this. I guess so. All right. So let's say this is going to be total equals, right? So once we got the total, all right, he was confused about the print actually. That's kind of weird. What happened here? Well, I can reduce this a little bit further if you want me to. We could, instead of the do, we could still use the arrow that we got used to before. And we can simply say this is, C plus E, which is the value. And I'm going to print that out. So in this particular case, we are simply writing this code to, he wants this all in together. All right, not bad. So again, as you can see, we're just using a specialized function. But how is this working? What's the magic he is performing? The inject method is an internal iterator, just like each is. But the difference is, each is simply calling the function. Whatever the function is returning, it's kind of discarding it. It's not using it. On the other hand, what this is doing is it says, I'm going to take an initial value of 0, bind the value 0 to C, and take the first element in the collection, bind it to E, give it to the function. It totals these two values, returns it, and inject takes the result value, binds the result to the variable C on the next call, binds E to the second instance in the element in the collection, let him process, and then sends it back. So it kind of chains the results until the last element gets exhausted and the result is given back to you. So once you understand how this works, you don't have to write a whole lot of code to get these things to work. Similarly, we could use hash tables. Hashes are basically like a dictionary, isn't it? Right? It's a collection of values, collection of objects that have a key value pairs. And you can use that to get various elements, various values out. You could use that too. But one of the interesting things about Ruby is, once again, its conciseness. So let's look at an example of how concise Ruby code can become. So let's say we have an age equals 18. And I could say, in this case, let's write a function. We know how to write a function, right? So can I vote? And I'm going to send an age to this function. If age is greater than 17, else, right? So in this case, I could say puts you can vote, or else I could say puts you can't vote, right? So I could call this function. I could say, can I vote? Ruby convention. Can I vote? So can I vote? And I can call this can I vote? And I'm going to send, let's say, 17 here. You cannot vote, sorry. A little bit more conciseness also you can enjoy. Parentheses is optional. Why bother putting it, right? Just ignore it. You can just put the variable, and then you can comma separate the parameters if you want to. I can also say, can I vote? And this is 18, and I can vote. Notice what I'm going to do here. Puts you can vote if age is greater than 17. So you can see how I told him what to do, then I say if that is true. Similarly, if I only have one calls to make like this, I could also say puts you cannot vote unless age is greater than 17. It's the same condition rather, but it's an unless rather than an if. I know it's a little getting used to, right? If you've never used unless, you kind of pause there and think for a minute. But once you get used to it, you begin to enjoy this conciseness. You say, do this unless that's, true, right? Or unless that's not true. So you could start writing concise code with these kinds of constructs, it becomes quite easy to write code with it. Writing functions, I just wrote a function as you can see here. You don't have to waste your time defining types. And you may say, oh my God, if you don't tell him what type it is, how do I know what the type is? Why do you care about what the type is? This is where duck typing comes in. So this leads to something more fundamental, and this is called design by contract versus design by capability. In language like C#, we do what is called design by contract. You establish this contract using interfaces and classes. Design by capability, on the other hand, has no interfaces. You go to an object and say, if you're willing to do this, sure. Here's an example, right? If I want to move this table a few feet forward, I could say, hey, can a man help me to move this? And a willing and able man probably is going to come and help me. And she, in the meantime, stubbornly sits over there and says, fine. He wants a man to help. Why should I help? Even though she is fine and healthy and willing, I just discounted her, right? And she's so happy that I did. Okay. But on the other hand, if I say, can somebody who can move this help me? I'm not specifying a type at this point. I'm going to say, I need help to move this. Can I get the help? Well, some man here can help. She can help. I could have an elephant maybe in the room that can come and help me to move stuff. And notice now, we no longer are tying ourselves to type information. We more care about capability. If you're capable of doing things, do it. So this is more of a handshake rather than a contract that is being signed ahead of time, right? So this becomes more flexible to work with and gives a lot more flexibility. That's where duck typing really comes in. So you can write these functions, but like we talked about, when you write functions, you have to return stuff from the functions, but if you don't return, the last expression gets returned from functions automatically. So you don't need to put return keywords. You could say, does it mean I don't have to put return keywords ever? Well, almost never. But there is one time, please. No, the language is statical, not statically typed. Yeah, right. So let's step back for a second. When you make an assignment, remember these are objects. So you are changing a pointer from one thing to another. So you didn't lose it, you just pointed to a different type, that's all you did. Because in the case of regular programming where you have variables and you modify their values, you are erasing the memory and rewriting on it. This is more a pointer pointing to a different value in that regard, right? So you didn't lose the original one, you're just pointing to a new one in this case. Now having said that, the distinction is static typing versus strong typing versus weak typing versus dynamic typing. They're orthogonal to each other. Static typing and dynamic typing are, parallel in comparison, meaning either it's statically typed or dynamically typed. On the other hand, you have strong versus weak. A language like Java and C# are statically typed and strongly typed. Language like Ruby is dynamically typed and strongly typed. Because at runtime, it knows what the type is. So if you try to mistreat it as a different type, you'll get an exception. So in a weakly typed language, like Perl and JavaScript, you won't get those errors. So that's where it's really strongly typed, but it's statically typed, not statically typed, it's dynamically typed. So here's an example. I could have a function, and imagine for a minute, imagine you're writing code in C#, and I want to call a function which is going to return a value for me, right? And it's going to return a random value, let's say. So we could say create random. Imagine this is C# for a minute. So this is, by the way, that's how you write comment lines. So let's say this is C#, and you want to return back a random value. Actually, you know what? I have C# open here, so let's go right in C#. How do you write this? So you would write something like this. You would say public static int create random, right? And what would you return here? You would then say return whatever the value is. Let's say we're going to just return 1 for this example. But what if I want to return 2 value? Even in C#, you could return a tuple. So you could say tuple of int comma int. And I love these tuple concepts because in C# you can return a collection of data using tuples. Very lightweight objects. You could do that. They don't have to pass rand 1 and rand 2. You just create a tuple and return its value. So how would it look? You would just say create random, and in this case you simply say return new tuple int comma int, and then value 1 and value 2, whatever those values are, right? You would just return it. So you could do that. But Ruby makes it a lot simpler than that. So if I want to go back to Ruby for a second, oops, wrong place. If I want to go to Ruby for a second, what would I do? Define, let's say, create 2, for example. And what do I do here? I'm going to return 1 and 2. So notice how I now use the return keyword. But I'm asking to return multiple values, not just one value. Again, this is where the language says I could be fairly flexible to you. How would I use it? I'll say result equals create 2, or create 2 using the Ruby convention. So now I can say print result. It's got both the values came in as an array. But you can also do this. 1 comma 2 is going to be the values that I receive, and I can print 1 and print 2. Notice how I was able to extract it into these values very easily. Where can you go with this? Notice what I can go with this. I could say A equals 4 and B equals 5. Let's print A and print B, right? So 4 and 5. And how about AB equals BA, print A, print B, and this allows you to swap it so easily. And to do little things. Imagine writing that code in other languages. You're writing some code, and after you finish it, you feel like crying, isn't it? Because that's so ugly to write. And you say, God, there's got to be a better way to write this code. And so you can write really elegant, concise code because of these multiple return values. It even gets better, by the way. What if I have a function called, return many? I don't know how many it's going to return, right? So maybe it's returning a return 1, 2, 3, 4, 5, and 6. And I say A comma sum equals return many. Print A. Now you're wondering, what does sum have? I heard 2 from somebody. I heard array from somebody. Who said array? Are you happy? No, right? It's like, give me my array back. I want it. You got it. So you say, I am greedy. He's greedy, isn't he? Be greedy. Notice how simple that was, right? You can say, I'm greedy. I want all of it, not just the second value. And you can just greedy stuff into the remaining elements. Not too hard to do, right? You don't have to put much effort to do that. So you can say these are the values I want, or I want to stuff the remaining values into it, and you can bring it fairly easily into it. So writing closures. How do you write closures? So you're at work one day, it's late in the evening, and you're asked to write a function that will total values, right? So you say define total values. You're given some numbers, and what are you going to do with this? You say total equals 0, return total, and within this you say numbers, let's make it plural, dot each element total plus equals element. Not bad, right? Easy to write. So let's say we have some numbers, nums equals 1, 2, 3. You know what? Let's do something else, some fun. Some nums equals 1 to 6. What is some nums? 1 to 6. It's a range object. But if I say for I in 1 to 4, and I say put I, that's 1 to 4. Notice how easy it is to use a range. You say, but I don't want 4. I want 1 to 3 only. Exclusive range. Exclude the last element, please. I had one guy, he said, what happens if you put 4 dots? No, no, no. Don't go there, right? There's no point doing that. And one guy said, what if you put 1 dot? That's called 1.5, double, right? So sure. But notice the flexibility you have, right? Coming back to this total values. What do we want to do? So I define some nums, let's call it nums, equals 3, 4. So every time this code runs, you're going to play a music like that for me? That's fine. I'm okay with that, right? So we have this nums that we have, printing it here. So what do? I say print for me total values for nums, right? That's the value that I want to print out for the given values. Let's print it out. That was simple, right? So you finish this. It's late in the evening. Your colleague wants you to write a function that totals all the values. Maybe these values are prices of stocks. When you're done, you're about to leave. You pick up your bag, and your colleague says, I need one more thing. I want you not only to total all the numbers, I still need it, but I want you to total all even numbers because my problem domain requires that. How do you do that? You say, okay, is this what you want? Total even values on nums. And your colleague says, yes, that's what I want. And you stare at this code. It's doing most of the work, but not all of the work. And you know it's morally wrong to copy and paste code, right? But it's late in the evening. It's beyond the moral time zone, right? So you quietly copy and paste it because you tell yourself there is a reason God created copy and paste, right? I mean, otherwise it wouldn't exist, right? So you copy and paste it, total even values, and you come down here and say, all right, let's make this a little bit pretty. Let's make it do, end. And what is this going to do? It says, given an element E for this particular loop, if E is even, then copy the total, right? That's what we're going to do. What did I do wrong? Line number 7. This is Ruby. So if that's true, do the totaling. Okay, I'll seek your help after I write this. Make it work, make it better. Make sense? But this code is a bit ugly and verbose. Can I do something about it? No? What can I do? Yeah? It works, right? You say, yep, that's done. Now that you're done so quickly, your colleague says, I need one more help from you. I want you to total odd numbers, please. But you look at your watch, you really have to go. You say, is this what you want? Total odd values, right? Say, yep, that's what I want. Odd values, right? And you know that should not be done. This is beyond all ethics, right? But once again, late in the evening, it doesn't matter. And it works, right? What did I do wrong here? Oh, thank you. Right? So you start going home, and on the way, the guilt eventually kicks in. You know this is not what you signed up for, right? That kind of bad code. And you tell yourselves you're going to refactor it. Because if friends come home and see this, what will happen? They get to know your dark side. They know what you're doing for a living, right? Copying and pasting code. Then they will never return your phone call. They won't hang out with you on the weekends. You invite them for a party, they don't show up. Oh, not him. He copies and pastes code. Not her. She does copy and pasting way of coding, right? So definitely we want to fix it. What do we do about it? So notice what we're going to do. Let's step back for a second. If you notice this code, ignore the name for a minute. Notice how, in fact, we can do one thing here. We could go back to this code just to kind of identify, and we could say, this is also very similar, except we just said, if true, right? So if you do that, all these three code are exactly the same, except for what? What's in the if, right? If we can extract the if out, hey, there's a pattern name for it. Do you know what that is? Strategy pattern. Right? It's a strategy pattern. We're going to apply the strategy pattern. I know that's scary, right? Because in C#, if you have to do strategy pattern, you invite corporate meeting. You have a design meeting, right? Email, memo, design meeting at 2 o'clock to do a strategy pattern. It's so simple, you don't have meetings, you just get it done. Let's see how. So how is this going to work? So let's get rid of this duplicated nonsense first, because we know duplicating code is evil. And we come down here and say, hey, I'm here, and I am going to yield the value E. Used yield in C#? Have you? Anybody? Yeah, few of us? Now you know where it came from, right? Very similar concept. Iterable can yield, and you can use that in C#, exactly the same concept. So what am I doing here? I'm yielding into it. So as a result, what it's going to do is I can call total values, send the numbers, and we can specify, given an element on hand, return true, because I want to accept all the elements that are given to him, right? So now I can print this result out, whatever that result is. So print the result of that operation. So right there is the result. Similarly, we can say print total values nums given an element E only if E is even. So you can check that. So you're using a lambda expression and you are creating a reusable piece of code. And the last thing I want to talk about is metaprogramming. I've got 14 seconds, but can I have 2 more minutes of your time? Yeah? So let's talk about, sorry, if she has to go. All right. So metaprogramming is one of the coolest things. It allows you to add methods at runtime. Let's take an example. I'm going to show you 2 examples here. We have a class string, stir equals hello, and I'm going to print the string, and it prints the value. But I'm going to say print string.encrypt, and I want to encrypt a string. What does it say? It says undefined method encrypt. I don't know what encrypt is. Maybe you write a separate encrypt method, and then you pass a string to the encrypt. It does encryption, and then it gives you back a result. And you call this all over, and you say, wouldn't it be nice if encrypt was given as a method? Right? But then you say, but it's a string class. I didn't write it. Well, you never feel that way in Ruby. So look at what I'm going to do. I'm going to say class string. Define encrypt. And what am I going to do in encrypt? I'm going to return an encrypted message right there. What did we just do? We opened an existing class. And we said, hey class, I want to give a method to you. Would you like one? And now you've added a function to an existing class. Classes are open. Can you do this in C#? What was it? Extension methods. You know where it came from. So extension methods in C# do exactly the same thing. You say, all right, that's cool. But more than method injection, there is something else you can do in Ruby. It's called method synthesis. And to me, method synthesis is more powerful than method injection. What is method synthesis? Method synthesis allows an object to learn. It's like what you and I do. You go around and somebody says, hey, do you know how to do this? No, but I'll be back tomorrow. I can burn the midnight oil. I'll learn everything about it tonight. And you assimilate behavior, right? So we can do that. Notice what I'm going to do. I'm going to say, I've got a class here called person. And what does this person do? This person is boring, can only work, like me. And it says working. So now I say, Venkat equals person, dot new. And we'll just say Venkat dot work. And what is Venkat going to do? Work, right? So work. But we'll make it a bit more interesting. We say sing. Okay, fine. Let's not do that. Right? Play. What do we want to play? Let's say play tennis. That's much safer than Venkat singing. So we want to play, right? What's going to happen when I run this code? It's going to fail because it doesn't have a play method. We could even go a step further. We could say play tennis. We could say play football. I'm not saying play cricket. I just can't do that so well. But I want all these methods. I want to synthesize these methods. How do I do that? Notice what I'm going to do. I'm not going to go back over here and write a play tennis method, play football method. Why shouldn't I do that? There's no end to it, right? Then you say play cricket, I got to go change the class. What's the good news about it? Job security. You keep changing this code. But after a while, you don't want that job anymore, right? It's like, oh, this got boring. Every time you want something, I got to go fix the code. So what is metaprogramming? Metaprogramming is you write a program that writes itself. I mean, why would you write code when you can write code that writes itself? Isn't that cool? That's exactly what we're going to do. So I go up to this class and I say, hey class, define missing method. Takes a name and arguments, a bunch of arguments as a parameter, and we will simply say, you called name. So essentially, what we are doing in this case is we are writing a method missing. And now notice what happened. You called play tennis, you called play football, it didn't error anymore. Instead it called, I love that music right there, right? Awesome. Method missing. So what is method missing? I call method missing as the mother of all methods. It says come to mama, right? When it doesn't exist. So that is the basic beauty of this method, is that it intercepts method calls. How does this help? How this helps is, you can call an arbitrary method now, and rather than complaining about it, it runs to this function and says, excuse me, this person called this method. What do you want me to do? And this method says, let me think about it. Hang on a second. Maybe I can apply some rules, some logic. Hey, guess what? I know there is a database schema. Let me go to the database schema and see if there is a field in the database that follows some convention. Oh, golly, there is one. Let me go grab the data for you and return it to you. And that's exactly what Ruby on Rails does. So Ruby on Rails basically starts right here. It leverages this part so you never have to write stupid code. Instead, you let the metaprogramming generate those code for you. And that minimizes so much effort. And this is the reason why there is so much excitement about framework like Ruby on Rails, because rather than you writing code, you synthesize code based on convention. And of course, when the convention is applied, if it realizes the method doesn't exist, then you get the error. So this gives you so much flexibility in code. And this is one of the reasons I really love programming in language like Ruby and Groovy, is because of this metaprogramming, where you can synthesize methods. This can save you so much time and effort. So I hope you found that useful. Thank you.